libraries so many times. It's going to be help us randomly. So we are going to get the data in terms of x train and x test and y train and y test. So let's go with the logistic regression. Intuition we haven't seen, I think. So yeah, these diagrams will help us to understand intuition of the logistic regression. So logistic regression is a supervised learning algorithm, and which is used for classification and also the regression purpose. But I can say in terms of regression, we have another technique called linear regression. So that will most probably going to be help us in terms of regression perspective. That means we have to calculate or we have to predict a real value number. In terms of classification perspective, logistic regression will going to be help us to understand. So what exactly the assumptions or what exactly the logistic regression when we're going to be applied. So when you have the data set which consists of large number of different transformations, I can say you don't know how to classify that model or how to classify that data. So at that time, we also perform something called nonlinear transformations, right? So nonlinear means if suppose that I can say, I think I have taken one plot. Yeah, this plot you can see here. So this is completely non-linear transformation. It may not be accepted these red points in terms of these blue points, right? So whenever you encounter something this curve like this curve, so this is not a curve exactly which we are going to see in the logistic regression every time. But what exactly we have to follow, it lies between 0 and 1, and it's also covered with whatever the two class classification settings, which is completely in terms of nonlinear transformation. So that's why we call it as the logistic regression to help us to understand. Here we're just using the whatever the line equations, y equals to mx plus c. So the slope, or in terms of that terminology, we use weights. So I think we also seen sigmoid function in earlier of the classes, that going to be looks like 1 minus 1 plus e to the power of minus x, that we are going to substitute in this logistic regression. That will help us to understand the nonlinear transformation. That is the curve looks like this. It lies between 0 and 1, obviously, because we are getting the probability scores. So that is a basic intuition behind the logistic regression, which we are going to apply on this case study, which we are also go see a lot of the details in the upcoming classes, like here, linear and logistic regression. For just to glance of this project, so we are just explaining the intuition only. We are going to say the mathematical equations also at the time. So let's go and implement the logistic regression here. We have in the scikit-learn, it will provide the linear model. Under linear model, we have the logistic regression. So in the logistic regression, lambda is the hyperparameter tuning. If you want to tune it, you can also go with something called a grid search and a random search. That will also be helpful to get the fitting of the hyperparameter. Here we are not going to that much of details, but here just applying the logistic regression to get to know about this prediction, whether the person is clicked or not. So just fit by using the whatever the x train and the y train we have. So just fit by using the logistic model. So it will going to compute some kind of the results by using whatever the test data set we have. So I think you are already aware of the AUC ROC results, which we have yesterday seen about. It is going to also give something called as a probability scores to evaluate it. And whenever you encounter 0.5 results of the above, that will going to be acceptable, I can say. This is just a custom implementation. You can also get it from the scikit-learn, like a library. You can directly import it, AUC ROC. This is just a custom implementation by using the true positive rate and the false positive rate. And we have to plot it by using the whatever the x test and y test values. So final results, I can say, like we have a classification of the report. In terms of the precision wise, we are getting 95%. So this is almostly equal to whatever the training data set we have. Training data set, we will get around, I think, 992 to 933. And in the tested, we are getting 91, right? So it obviously gives us such good results. In terms of the recall also, it's almost giving the same value when compared to the training data sets. So I think you may aware of the F1 score. This is the harmonic of the precision and the recall perspective, right? So we have to be encounter like a, some of the customers maybe click on this ad in terms of whatever they have clicked in previously. Like a precision is going to be tell us about how much percentage of the points or how much percentage of the customers is going to be clicked previously that ad. It may be possible to click that ad in the future. So that's what the precision is going to be tell us. And how exactly the AUC ROC curve going to be looks like, we have to see it. So this is the AOC ROC curve finally. So we are getting the value around 0.8, right? So it's almostly very good results, I can say, when compared to the precision and recall also. But in terms of the AOC ROC result, it may be happen sometimes, it may not be happen, but this is just a small data set which will also perform in terms of large data sets that might be helpful factor, but it's going to be looks like something called overfitting. So we're going to see what exactly the overfitting and underfitting. So in terms of various and bias trade-off. So those concepts will comes and we'll learn later. But as of now, you can see the AOC RVC results we are getting good results, but in terms of perspective of the training and test data, it may not be helpful factor. So that's what all about. And we also perform some of the hyper tuning mechanisms, but I'm not going to the